Recent research tells a new, tumultuous story about the origin of Oumuamua, the strange object that left many questions in scientists' minds during its unexpected visit to our solar system. Astronomers have provided a very simple explanation for Oumuamua, the first interstellar object discovered in our Sun's domain. In October 2017, an unknown object with an unusual shape was observed moving through the solar system. Its cigar-like appearance and strange movement intrigued many theorists in the field of extraterrestrial life. However, recent study results reinforce the hypothesis that it was likely just a small asteroid that separated from a larger celestial body due to gravitational forces caused by a close pass in another star's orbit. The strangeness of this object is thought-provoking to astronomers for several reasons. For example, Oumuamua had a very elongated shape, appearing somewhat like a massive space cigar, and may have been somewhat flat. Prior to this, astronomers had never observed any celestial object with such an appearance. Moreover, during its brief visit to the solar system, Oumuamua exhibited a type of non-gravitational acceleration. This behavior cannot be attributed to gravitational interactions with larger bodies such as the Sun and Jupiter. In fact, we had previously only observed such movements, apart from spacecraft, in comets, which can display accelerated motion by absorbing heat from their surroundings and releasing internal gases. However, the problem was that in scientists' observations, no signs of gas emissions from Oumuamua were detected. No tail or gas cloud was seen around this object. This contradicted the theory of its being a comet, which are the only types of known celestial bodies that can travel through interstellar space after getting away from their host stars. Finally, the very fact of observing Oumuamua is itself strange and enlightening. Considering the infinite expanse of space, the vast distances between stars, and years of fruitless efforts to explore similar objects, one must recognize that there are likely many more objects similar to Oumuamua than previously thought. The unique characteristics of Oumuamua have led some scientists to propose that it might have been some kind of extraterrestrial spacecraft. However, the new study offers a logical explanation for Oumuamua's unusual behaviors. Zhang and Lin have attempted to simulate the effects of various objects flying close to stars. Their modeling showed that objects encountering certain close passes might break into elongated pieces and be ejected into interstellar space. The intense heat generated during the close encounter, followed by rapid cooling, could lead to the formation of crusts on these objects. He adds, however, some volatile materials with high sublimation temperatures, like water, buried beneath the surface of these bodies can still maintain their compact state. The researchers suggest that these hidden volatile materials could reactivate when encountering other stars, like the Sun, releasing gas and thereby accelerating the object without the need for gravity. This study indicates that such an event could occur for a wide range of parent bodies. The recent study, published on April 13 in Nature Astronomy, states that the ejected fragments could include pieces of comets, small planetary debris, or even larger planets that experienced close encounters with stars, ultimately being ejected into interstellar space. It is worth noting that stars do not necessarily need to be in their active phase for such conditions to occur, hence, ultra-dense objects, like white dwarfs, could also suffice for such maneuvers. Zhang states that these interstellar objects could provide evidence related to the formation and evolution of planetary systems. Today, we know that Oumuamua is not the only traveler from interstellar space that has passed through our solar system. Now that Oumuamua has exited the solar system and entered the vastness of interstellar space, permanently leaving our line of sight, it might be best to search for similar objects in the boundless expanse as far as we can. As we continue to observe other interstellar objects in the coming years, it will be very interesting to determine whether any of these will exhibit characteristics similar to Oumuamua. If the answer is yes, we can conclude that the processes outlined in this study are common.